Hello everyone, I'm Siddharthan. Currently, we are in the fifth module of our hands-on machine learning course with Python, and this fifth module is all about mathematics for machine learning. In the previous video, I have explained you about what are the different matrix operations that we can do, and in this video, we are going to implement those matrix operations in Python. So this will be a very interesting hands-on video where we will try to implement all those things which we have learned conceptually in Python. Okay, so in case you are watching my videos for the first time, hi. In this YouTube channel, I'm making a hands-on machine learning course with Python. And if you want to learn this course from the beginning, just go to the playlist section of my channel where you will find videos module wise. So each module contains multiple videos. So start learning from the module one. Okay. So with that being said, let's get started with today's video. Okay. So the four matrix operations that we have discussed are matrix addition, matrix subtraction, multiplying a matrix by a scalar, and multiplying two matrices. So these are the four operations that we are going to do in Python. Okay, and I'll also give the link for a quiz in the description of this video, and this quiz contains several questions based on the programming and based on the codes that I'm going to do today. Okay, so you can answer that questions once you watch this video. So if you watch this video completely, you can answer all those questions correctly. Okay, so it will be a very good exercise for you. And also after watching this video, practice all these codes by yourself. So this will be like an assignment for you to practice. Okay, so let's get started. The first step is to import the library that we need. So for creating matrix, we need Numpy library. So I'll just make a text here describing what I'm doing in this code. So in the first step, I'm going to import the Numpy library. So importing Numpy library, and Numpy stands for numerical Python. So it is useful for making several arrays called as NumPy arrays, and we are going to use these NumPy arrays as matrices. Okay, so this particular environment is called as Google Collaboratory, in case you are not aware about this. So in this Google Collaboratory, this is a cloud-based environment where we can run Python programs. So you can connect your system from here, then you can run your Python program in this cells. Okay, so just go to Google and search as Google Collaboratory. So you will go to this site collab.research.google.com. Here you can run your Python programs. Okay, so this is very useful for machine learning, deep learning, and data science projects. So now let's get started with our code. So the first step is importing NumPy libraries. So let's import NumPy as NP. Okay. So what we are doing is importing NumPy in a short form as NP. So instead of mentioning NumPy every time, we can mention this short form as NP. Okay. So the first operation which we are going to discuss is matrix addition. So matrix addition. So I'll just make a text here. So in order to run a cell and go to the next one, so in order to execute a cell and go to the next one, you can press shift plus enter. Okay, so I'll just make this as bold, and you can press shift plus enter. This will automatically run the cell and go to the next one. So there is one main thing which we need to take note of in matrix addition. So we can add two matrices. So two matrices only if they have the same shape. So I'll just make a text here as two matrices can be added only if they have the same shape. Only if they have the same shape. Okay, so we have discussed about this in the previous video. I'll also give the link for the previous video in the description of this particular video. So shape is nothing but the number of rows and columns. So now let's create two matrices. So I'll just make a comment here as creating two matrices. Okay, so let's name this matrices as A and B. So let A matrix be A is equal to np dot array and np dot array. Inside this we need to put some square brackets. So this is the overall square bracket, and inside this we need to mention the rows of our matrix. So we need to open two other matrix. So I want to create a 2 cross 2 matrix. So 2 cross 2 matrix represents a matrix with two rows and two columns. Okay, and the values of the first row should be put in this first square bracket, and the second value should be enclosed in this second square bracket. So let's put this values as 2 comma 3 and 4 comma 5. So 2 comma 3 will be the values of the first row of our matrix A, and 4 comma 5 is the values of second row of our matrix A. So now let's create another matrix as B, and B is equal to np dot array. So NP is the NumPy library which we have imported, and array is the function that creates this NumPy array which we are using as matrix. So NumPy array, and similarly we need to create two square brackets for two arrays of matrix. Let's put the values as 6 7, so you can just give any values you want. Okay, so I'll just take this simple values. So 2 3 4 5 and 6 7 8 9. Okay, so these are the two matrices, so A matrix and B matrix, and you can print this matrix and see. So I'll print A first. So let's take this as capital A, and you can see here now we have a matrix with the values as 2 and 3, which comprises of the first row, and 4 and 5 are the second row. So similarly, you can print the B matrix which has the values as 6 7 8 9. Okay, so you can see here, so the first set of values 2 and 3 will be the first row, and the second set of values will be the second row. So this is how you can create two matrices using this np.array function. Okay, so let's say that we want to find the shape of this matrix. So mention the name of the matrix. So in this we have named the matrix as A, right? So A dot shape. So this shape function will give us the shape of our matrix. So here it tells us that it is 2 comma 2. Here the first value represents the number of rows, and the second value represents the number of columns, right? So here we have 2 rows and 2 columns, so that is what it has been given here. So this particular matrix contains 2 rows and 2 columns. So I have already mentioned here that two matrices can be added only if they have the same shape. So the shape of A should be the same as shape of B. So let's also check the shape of B. We know that it's 2 comma 2, but let's check this anyway. So it is a good practice. So you can see here both of these matrices have the same shapes, so we can add these two matrices. So what happens when you add two matrices is that all the elements, so or all the values will be added element wise. Say for example, in this case, if you add A and B, this 2 will be added with this 6, and this 3 will be added with this 7, 4 will be added with 8, and 5 will be added with this 9. So element wise addition will take place. So now let's add these two matrices. So I'll just put a text here as adding two matrices. So let's name this addition matrix the resultant sum as sum. So this will be the resultant matrix which we are adding. Okay, so just change it here. Okay, so now you just can mention it as A plus B. So this will give you the matrix addition product, or the resultant of the matrix addition. So A plus B, and then you can print this sum to see what is the answer you are getting. Okay, now you can see here. So we know that there will be element wise addition, and 2 plus 6 is 8, and 3 plus 7 is 10. So you can see here it is 8 10 12 and 14. So we got element wise addition. So this is how you can perform matrix addition in Python. So there is another way of doing it. Okay, so let's see how we can do this in a different way. And for this, let's take two matrices with random values. So here we just gave the values, right? Now let's take values, or let's take matrices with random values. So I'm going to create two matrices with random values, and let's name this as matrix 1 will be our first matrix, and this first matrix is equal to np dot random dot randint. So this random dot randint is the function which will give us a matrix with random values, and inside this you need to mention a value. So in this I'll mention 10. So this means all the values will be less than 10. If I mention 100 here, all the values will be less than 100. So I'll just take a smaller value 10. Okay, and there is another parameter which we need to mention, which is equal to size. Okay, so size, let's put the size as 3 comma 3. What happens here is, so this is the shape of the matrix. So it is a 3 row and 3 column matrix, and what happens is it will create a matrix with 3 rows and 3 columns with all the values as a random values, but all the values will be less than 10. So this will be our first matrix. And let's create the second matrix as matrix 2, and matrix 2 is equal to np dot random dot randin. So rand int means we are just getting random integer numbers. If you just mention random dot rand, you will just get floating point numbers. So those values will be less than 0. So it will be like 0 0.01, 0 0.1, 0 0.2, some things. Okay. But if you mention rand int, it will give you random integer values. Okay. So I want random integer values. So rand int, now let's say that I want all the values to be less than 20. So that will be our matrix 2. And we know that the shape of the two matrix should be same if we want to perform matrix addition, right? So in the previous case for matrix 1 we took the shape as 3 comma 3, so it should be the same 3 comma 3. So let's run this. Now you can try to print this matrix 1 and matrix 2. So I'll print this matrix 1 and matrix 2. So here you can see here it contains random values. So we didn't give these values. So we just mentioned that all the values should be less than 10. And I want a 3 cross 3 matrix. So we got a 3 cross 3 matrix with random values less than 10. In this case, we got a random values less than 20. So this is how we can get matrices with random values by mentioning their shape and the values under which we want the values to be. Okay, so now let's see how we can add these two matrices in a different way. So in the previous case, we have just used this addition symbol, right? Instead of this we can also do this. So I'll create this also as the sum. Okay, so sum is equal to np dot add. Okay, so np is nothing but the numpy library, so it has the function add, and inside this parenthesis mention the two matrices which you want to add. So I want to add matrix 1 and I want to add the matrix 2. Okay, so let's run this, and now you can print sum. So this will give us an element-wise addition of these two matrices. So 2 plus 18 is 20 and 7 plus 17 is 24 and so on. So this is how you can add two matrices using this numpy or np.add function. Okay. So I have already mentioned you, right? The shape of the two matrices should be similar to perform this addition. Let's change this shape and see what we are getting. Okay. So I'll just copy this code here. And now I'll just change the shape of this matrix as 3 comma 4. Here we can tell that the shape of these two matrices are not equal, right? So this is a 3 cross 3 matrix and this is a 3 cross 4 matrix, and this cannot be added. Yet we can check this. So I'll just put sum. So sum 2. So let's name this as sum 2, and I'll just name this matrix as matrix 3 and matrix 4. Okay, so this is sum 2, which is equal to np dot add matrix 1 and matrix 3 and matrix 4. Okay, so let's run this. Now you can see here we are getting an error as operands could not be broadcast together with shapes 3 comma 3 and 3 comma 4. Operands is nothing but this matrix 3 and matrix 4. Here the plus symbol, the addition is called as the operator, and the two values are two matrix which we are adding is called as operands. So operands cannot be broadcasted. That means like these two matrices cannot be added because they are not of the same shape. So the shape of the first matrix is 3 comma 3 and of the second matrix is 3 comma 4, hence we cannot add these two matrices. Okay, so this is the proof which we have been talking about. So this is how you can add two matrices with similar shapes. Now I'll just mention this reason for this error. So I'm not going to clear this error, so it is helpful for us to understand why we are getting it. So I'll just make a text here as we get this error because shape of matrix 3 and matrix 4 are different. Okay. Okay, so the next thing which we are going to discuss is matrix subtraction. So we know that matrix subtraction is also similar to matrix addition, right? So everything is similar about it. So subtraction. Okay, so now similarly, I'll just go ahead and copy this code and let's subtract the values. So I'll paste it here. So we will get two matrices A and B. So we have already printed and seen how A and B looks like and what is the shape. It is a 2 cross 2 matrix. B is also a 2 cross 2 matrix. And let's create a variable as difference. Okay, so this is the value. So difference is equal to A minus B. So A minus B. So we are just subtracting the two matrices. So let's run this and print this difference. Before that, I'll just print this A and B as well so that we can understand this. So print A and print B. Okay, so Here we can know that we are just a minus b, right? So that means 2 minus 6. So the first value should be minus 4. 3 minus 7, the second value should be minus 4. Let's see whether we are getting the answer. So let's run this and print the difference. Okay, so the name difference is okay. So I just made a mistake here. Okay, now you can see here 2 minus 6 is minus 4, 3 minus 7 is minus 4, 4 minus 8 is also, so everything is minus 4. Okay, so we know that element wise subtraction is done, and this is how you can find the matrix subtraction of, when you take two matrices. And the important thing to note here as well is the shape of the two matrices should be similar. So in this case, what we shall do is similarly we can just copy this two random matrices. I'll just paste it here. And now we are creating similarly two random matrices with 3 cross 3 matrix with all the values less than 10 on all the values less than 20. Okay, so let's run this. You can print this matrix 1 and matrix B. So matrix 1 and matrix B. So this will be different from the one which we have created before. So because like every time it creates new values, so the same values won't be created, so that's why it's called as random values. So it will create random values, and here you can create another method. So here we have used this np dot add, right? So we have used this np dot add. Similarly, we can use another function from numpy as diff is equal to, let's give a short form for difference as diff is equal to np dot subtract. Okay, so np dot subtract, mention the two matrices which you want to subtract. So matrix 1 and matrix 2. Here the matrix 1 are these two matrices. Okay, so matrix 1 and matrix 2. So let's run this and print the difference. So this is how you can subtract the two matrices using this np dot subtract. So one way is using this a minus b, so just using this minus symbol here, the subtraction operator here, or you can just use this np dot subtract function to do this subtraction. So similarly, if you just go ahead and change the shape of the matrix, if you just give two matrices with two different shapes, you will get this similar error with this np dot subtract function. So you can try that out. So the next operation which we are going to discuss is multiplying a matrix by a scalar. So we have discussed this in the previous video, right? So when you multiply a scalar is nothing but a single value, single numerical value. Let's say that we are taking a scalar value like 5. So when you multiply a matrix by a scalar value 5, all the elements in the matrix will be multiplied by this value. Okay, so let's understand this in Python. So I'll make a text here as multiplying a matrix by a scalar. Okay, so I'll take two variables here, x, and let's put x is equal to 5. Okay, so this will be our scalar because it is just one value, right? So scalar is nothing but which contains only one numerical values, and matrix contains rows and columns of values. And y will be our matrix. So np dot array. So we know that we can create arrays or matrix with using this np dot array function, right? So np dot array, and we need to mention the rows of this matrix. So I'll mention the square brackets here. Let's take some random values, or else, so instead of this we can just take some random values. That's better. So np dot random dot randint. So random dot randint, and I'll take the values less than 10. So let's take smaller values itself. So 10 size is equal to let's take 4 comma 4. So you can take any shape you want. So what I'm doing is, so I'm taking x as a scalar value which is equal to 5, and I'm creating y which is a random matrix with 4 rows and 4 columns, and all the values will be less than 10. So I'll also print this y. Okay, so now let's see how we can multiply these two matrices. So product. So let's create a variable as product, and let's store the multiplication product in this particular variable. So for this we are going to use the function np dot multiply. Okay, so np dot multiply, and x comma y. Here x represents the scalar which is 5, and y represents the matrix. So let's run this and print this product. Print y, or print product. So now you can see here when 0 is multiplied by 5 we get 0, when 4 is multiplied by 5 we get to 20, 6 into 5 is 30, 7 into 5 is 35, and so on. So this is how you can multiply a matrix by a scalar. So whenever you are multiplying a scalar by a matrix, all the elements in the matrix will be multiplied by that particular numerical value. So this is how we can perform this particular operation in matrix. Okay, so I'll just make this as bold. So now let's discuss how we can multiply two matrices. Okay, so two matrices. So we have discussed this detailedly in our previous concept video on matrices operations. So I'll just make a text here as multiplying two matrices. So if you are not aware or if you are not sure how this matrix multiplication works, please go and watch the previous video. I have explained there detailedly on how this works, and there is a condition for this. So I just go to this presentation which I have explained in the previous video. So the condition for matrix multiplication is that, so you can see the rule here. The number of columns in the first matrix should be equal to the number of rows in the second matrix. So this is very important. In the case of addition, the shape should be exactly similar, but it is not the same. The number of columns in the first matrix and the number of rows in the second matrix should be similar. So you can just consider this example. Here you can see here we have 2 cross 2 matrix and 2 cross 2 matrix. So here the second value represents the number of columns and the first value represents the number of rows, right? So as per the rule, this value, this number of rows in the first matrix should be equal to this value which represents the number of rows. Here the values are similar, right? Hence these two matrix can be multiplied. So that's what I have mentioned here, and the resultant matrix will have the shape of the remaining values. So here we have this 2 and 2, right? So this will be the shape of our remaining resultant matrix. Okay, so now let's check this for this matrix. So this is a 3 cross 2 matrix and this is also a 3 cross 2 matrix. If you check this rule here the number of columns in the first matrix is not equal to the number of rows in the second matrix. Here it is 2 and here it is 3, so it is not equal. Hence we cannot perform matrix or matrix multiplication between these two matrices. So this is the main rule when you are dealing with matrix multiplication, and this is how matrix multiplication works. So if you are not aware, please go and watch this video. So this is very important on how to understand how this particular multiplication works, and I'm not going to explain this now. I'll just try to implement this because I have already explained this. So now let's see in Python how we can do this. So we cannot use this np.multiply function, so it will just do element wise multiplication. So for this we need to do another important function using numpy. So let's create two matrices, or I'll just copy this from above. Okay, so let's copy this where we created random values, right? So let's create random values again, but I just want smaller values. I'll just take random values less than 5. Okay, and we know that the number of rows in the first column, sorry, the number of columns in the first matrix should be equal to the number of rows in the second matrix. That means this value should be equal to this value. Here both of them are 3, right? So these two matrices can be multiplied and the resultant matrix will have the shape as 3 into 4. So 3 row and 4 column. Okay, so these two values should be similar. If these two values are similar, then we get a resultant matrix of this shape. Okay, so let's run this and let's print matrix 3 and matrix 4. So print matrix 3. So this is the random matrix with all the values less than 5. And let's print matrix 4. Okay. Now, as it satisfies the condition, we can go ahead and multiply these two matrices. For this, we are going to use another numpy function, as I have told you earlier. Let's also name this as product. Okay, so product is equal to np dot. So this dot function will give us the matrix multiplication that we want, and inside this parenthesis mention the two matrices that you want. So matrix 3 and matrix 4. So these are the two matrices for which I want to find the multiplication value, right? So I just print these values, print product. Okay, so this is the resultant I'm getting. So you can go ahead and check the shape of this product. Okay, so product dot shape. So when you check this, we can get the values 3 comma 4, which I have told you earlier. So we need the number of columns in the first matrix, which is 3 in this case, should be equal to the number of rows in the second matrix, which is 3. So these two matrices are compatible to do matrix multiplication. The resultant will have the shape as 3 into 4, the remaining two shapes. So we got a matrix with the values as 3 and 4, and you can cross check how this values come. So as I've told you earlier, I've explained in that video. And if you perform the matrix operations manually based on how I have explained you in this particular video, you will get these values as the resultant product of the two matrices. So what happens is, this first row will be multiplied with this first column. So this 4 will be multiplied with 3, and 2 will be multiplied with this 2, and this 2 will be multiplied with this 1. Okay, and all these values will be added. And when you take the second, so when you do that, you will get the value as 18. So now let's take the second value as 12. So what happens is, in this case, this first row will be multiplied with this second column. So 4 will be multiplied with 1, and 2 will be added, or sorry, 2 will be multiplied with this 2, and this 2 will be multiplied with this 2, and all the values will be added, and you will get the value as 12. So similarly, all the values will be calculated, and this is how you can find the multiplication of two matrices. Okay, so now let's check whether it is compatible for all the shapes. So I'll copy this and paste it here. We know that these two values should be similar, right? So here what I'll do is, I'll just change this shape as 4. Okay, so here we can say that the number of columns in the first matrix, which is 3, is not equal to the number of rows in the second matrix. So this is not compatible, right? So I'll run this, and now I'll give this product is equal to np dot matrix 3 and matrix 4. Okay, so let's see whether we are getting. Now you can see here we are getting an error. So the error is shapes 3 comma 4 and 4 comma 4 not aligned. So 3 dimension 1 is not equal to dimension 0. So this is what I have told you. So this 3 and sorry, this value and this value should be equal to do the multiplication. Here the two values are not equal, so that has been shown here as 3 is not equal to 4. So this exclamatory mark and equal to represents not equal to, right? So we know that. So that is what is given in the error. So for carrying out the matrix multiplication, the important thing for us to note here is the number of columns in the first matrix should be equal to the number of columns in this rows in the second matrix. So in the last video and in this video, I have repeated this line multiple times. So you could have noticed that, because this is very, very important. Okay, so this is how you can carry out matrix multiplication. So that is another type of multiplication which we need to discuss. So I'll just copy this and paste it here. Okay, now we are going to perform another multiplication, but I'll just change the value as 3 comma 3. So now we are creating two matrices. One is matrix 3 and matrix 4. Now what we are going to do is element wise matrix multiplication. Okay, so we did multiplication. Okay, so in the previous steps we did element wise addition and subtraction, right? So similarly we can do element wise multiplication as well. So let's see how we can do that. So previously, I'll just make this bold. Okay, so previously we have used this np dot multiply, right? So I'll just go here. Okay, so we use this np dot multiply for multiplying a matrix by a scalar, right? So one second. Okay, so we can use this same function, which is np dot multiply, to do element wise multiplication. So here we have two matrices. You can just print this matrix 3 and matrix 4. Okay, so matrix 3, and I'll print this matrix 4. Okay, so now I'm going to find element wise multiplications or element wise product. So I'll name this as product, which is equal to np dot multiply. So the same function which we have used before. So np dot multiply matrix 3 and matrix 4. Okay, and let's print this. So print product. Okay, so this is not similar to this particular case where we have this particular np dot is different here. This is not element wise multiplication, so this multiplication concept is different, whereas this is element wise multiplication where this 3 and 4 will be multiplied element wise. So this 1 will be multiplied with this 1, 3 will be multiplied with this 0. So you can see the results here. So 1 into 2, which is equal to 2, and 2 and this 2 will be multiplied, which is 4, and this mid value, which is 3, will be multiplied with this mid value 2, which gives 6. So similarly, all the values will be added element wise, and for this to happen, both the matrices should have the same shape. So similar to addition and subtraction. So if you just copy this and paste it here, and if you just change any one shape here, now this will give us an error if you just use this np dot multiply, because we have different shape for 3 and 4. Okay, so this will show as an error. Okay, so the important thing to note here is for np dot multiply to work well, both the matrices should have the same shape. So these are the main operations that we have discussed today. I'll just give you a quick recap in case you have missed something. So first we are importing the numpy library, and this numpy library is used for making arrays. Okay, and then we are creating two arrays, two simple arrays, and we have named this arrays as a and b, and we have used this a plus b to find the sum of the two matrices. And the in matrix addition, the important thing to note here is the shape of the two matrices which we are adding should be same. Okay, and then we have discussed about matrix subtraction. So we have just changed the shape of the matrix, and saw that we are getting an error. And then we have discussed about matrix subtraction. So it is similar to matrix addition. In this case also, we need same number of rows and columns in both the matrices, and we have used this a minus b. And in this case also, we have used this np dot add, right? And in this case, we have used this a minus b also, and also this np dot subtract function. And then we have used this np dot multiply function to multiply a scalar to a matrix. So we are multiplying a matrix y by a scalar x, which value is y, which value is 5. Okay, so this is about multiplying a matrix by a scalar using this np dot multiply function. And then we have seen how we can multiply two matrices. Okay, so in this case, the number of columns in the first matrix should be equal to the number of rows in the second matrix, and we have found the result of this particular matrix. So you can cross check this. And also finally, we have seen how we can, so for this we have used this np dot function, right? And finally, we have seen how we can perform element wise matrix multiplication. So these are the topics I wanted to cover today, and I hope you have understood all the things covered here. And don't forget to check out the quiz in the description of this video. So do practice this codes as well, and also try to answer the questions in the quiz. Okay, so that will be a very good exercise. And that's it for this video, and I'll see you in the next upload. So thanks for watching.